Hi students, good morning. Sorry. Am I audible properly? Okay. So today we are going to discuss current electricity chapter, and I want to share with you that I have gone through all your feedbacks and thank you for sharing it honestly, and based on your feedback only I have reduced the content and increased the PYQs. Okay, so I hope that's clear for all. And I think some of you suggested that, not everybody, like one student suggested me that they want class in Hindi. Are all others okay with that? Okay, if everybody is okay, like I can like ask explain something in Hindi also. So let's start today's class. Okay, in current electricity, few of the topics which we will be discussing is current density, drift velocity, resistance and resistivity, combination of resistor, grouping of cells, that is combination of cells, KVL, KCL, Wheatstone bridge, galvanometer. So these are the major areas from which the questions will come. Okay. Now if you are going to current density, what is current density? Usually when we say density, it is mass by volume. If you say some other density like electron density, it is number of electrons per unit volume. Okay, but current density is current passing through a perpendicular surface. Okay, so current by area. So this is current density. Okay, this one, I by A, it is a vector quantity. Its direction is perpendicular to that surface. Okay, that is the direction of current density. And how we are getting these equations, we will come later. This is from drift velocity. Okay, if you know drift velocity, current can be said that NEAVD. Okay, N is number of electrons per unit volume, that is electron density. E is charge of electron. Here Q also means whatever charge is present, its charge. Usually it is electron in current density. So NEA is area of cross section, VD is drift velocity. Okay. Next, about drift velocity. If I am explaining it, drift velocity मतलब अगर हम like दोनों terminals का potential लगा रहे हैं किसी wire में, what happens? The electrons will move towards the positive terminal, right? And will it move with acceleration or constant velocity? Like if there is potential, positive potential, it is attracting electrons, it moves with force, right? Electrostatic force. So which means electrons are moving with acceleration. पर अगर हम एक साथ लाइक एक कंडक्टर में देख रहे हैं, सारा इलेक्ट्रॉन्स का एवरेज वेलोसिटी निकल रहा है, दैट विल बी ए कांस्टेंट वैल्यू. इवन दो इंडिविजुअल इलेक्ट्रॉन्स आर एक्सेलरेटेड, as a total average velocity of electrons will be constant, and that value is drift velocity. Okay, is it clear? And its formula we will get drift velocity equal to EE. This is our electrostatic force divided by m. So force by mass, acceleration into time, you will get velocity. This is the meaning of this formula. Okay, and this tau is nothing but average relaxation time. Relaxation time मतलब दो कोलिशन के बीच में जितना टाइम होगा वो है रिलैक्सेशन टाइम. टाइम बिटवीन टू consecutive collisions. Why is this? Because electrons will hit other like in the first page, as you can see, when there is a resistance, electrons will collide with these resistance also, they will collide with each other also. So that is what creating the collisions in the resistor, and time between two successive collision is relaxation time. Okay. Next is from our previous equation of drift velocity, Vd can also be said as I by NEA. From this we will also get another term called mobility. Mobility of electron means we are explaining how easily it can move through a conductor. Okay, mobility is equal to Vd by E. Is like these and all direct formulas only required. You don't need the concept for solving problems with respect to this. Can we move to the next then? Okay. Next is, based on the formulas which we learned, we are explaining resistance with a new formula. Okay. So for what I we got as I equal to NEA Vd, right? And for Vd we got another equation with electric field. So we are substituting that equation here instead of Vd. Now electric field can be said as potential per unit length. So we changed electric field into that. Okay, this is separate, this is separate. And from this we are applying Ohm's law there. What is Ohm's law? Ohm's law is V by I equal to R, or V by R equal to I. So in comparison V यहाँ है, I यहाँ है, so बाकी जो चीज़ है वो सब मिला के R बन जाएगा. Okay, so from that we are getting R equal to this. Okay. And for R we have another equation, that is rho L by A. When we compare L, L, A, so rest of these things will be resistivity rho. Is that clear for all? How the formula is coming? Okay. Now as you can see, there is a time factor in resistivity and resistance, relaxation time, which means the resistance and resistivity depends on relaxation time. Relaxation time का क्या है, वो depend करता है temperature में, because why? When temperature increases, energy of individual electron will increase, which means they will move more randomly and they will collide more. So relaxation time will decrease when temperature is increasing. If this is decreasing, denominator is decreasing, the value will increase. That's why we say for conductor, when temperature rise, resistance rises, and we can explain it using this formula. Okay. R at any point is equal to R naught. R naught is resistance at 0 degree Celsius or 0 degree Celsius, let's take, into 1 plus alpha naught delta theta. Alpha is defined at temperature 0. Okay. Delta T is change in temperature. So when temperature changes, how much resistance changes, we can get from this formula. And how it is related to that? Because of relaxation time. Okay. Is it clear for all? Rest of the things I won't be explaining this much. ये कुछ डिफ़िकल्ट है इसलिए मैंने एक्सप्लेन किया. ओके. नेक्स्ट वन इज, आप देखते होंगे लाइक ऐसा क्वेश्चन, इनिशियली ए वायर वाज एट सर्टेन लेंथ एंड सर्टेन एरिया, देन वी विल elongate द वायर टू बी सम अदर लेंथ, व्हाट विल बी न्यू रेसिस्टेंस. ऐसा क्वेश्चंस आते हैं, तो हमें पता चलना चाहिए कि लेंथ चेंज करने से एरिया में क्या चेंज आएगा. इट्स ईजी. पहले और लाइक फर्स्ट और सेकेंड, फर्स्ट टाइम एंड सेकेंड टाइम वॉल्यूम इज सेम फॉर द मटेरियल. वॉल्यूम मीन्स एरिया इंटू लेंथ. सो इनिशियल एरिया इंटू लेंथ इक्वल टू फाइनल एरिया इंटू लेंथ. सो वी विल गेट L1 बाई L2 इक्वल टू A2 बाई A1. इसका मतलब क्या है, लेंथ जब बढ़ रहा है एरिया कम हो जाएगा. when length is shortened, area will increase. Okay, so it's a relation like that. And what happens to resistance? Resistance is equal to rho L by A, right? So R1 equal to rho L1 by A1. R2 equal to rho L2 by A2. When you take, like, divide R1 by R2, you will get in this form. Okay, so only length is given. L2 by L1 is given, then you can say A1 by A2 is equal to, again, L2 by L1 into L2 by L1, which is equal to L2 square by L1 square. Okay, so only when length is given, length change, and only area change is given, you can find resistance change. That is the use of this formula. Is it clear? Not clear? Okay. Do you want explanation in Hindi or English? I think Dhanasri didn't understand. Do you want explanation in Hindi or English, Dhanasri? English, okay. So you have seen the questions that, like, initially a wire is having L length. Then we stretch the wire for 2L length. What is the new resistance? Okay. So if only length change is given, you know nothing about area, still you can find change in resistance. Let's say initially it is having R1 resistance and L1 length. So this is its formula. Then it is having R2 resistance when length is L2. If you want to find R2, R2 by R1 will be equal to L2 by L1 into A1 by A2. Okay, just taking the division here. And R2 will be equal to what? R1 into this thing, L2 by L1, A1 by A2. Then by comparing volume, because volume won't change, right? If you stretch something or compress something, volume will be same before and after. Comparing that, we will get this formula. So A2 by A1 equal to L1 by L2, which means A1 by A2 equal to L2 by L1. Substituting that, you will get R2 will be equal to R1 times L2 square by L1 square. Now you understood? So only if length change is given, you can find. Only area change also given, you can find. A2 by A1 equal to L1 by L2. So L2 by L1 equal to A2 by A1. So it will be understood? Okay. Then let's move on. Next is combination of resistor. I don't want to explain this because you already know this. If it is connected in parallel, we have to add the reciprocal. Series में connect किया है, we will directly add. So I don't think you need much more explanation in this. Can we move on? Okay. Next is cell grouping. Cell grouping also same thing. First thing you have to remember, cell is having internal resistance. हर एक cell में एक internal resistance होता है. Okay, we represent it using small r most of the time. And equation for finding the small r internal resistance ऐसा है, like V equal to EMF minus IR. This is the equation we have, which means R equal to what? Epsilon minus V divided by I. If you do this, you will get what is R. For example, ये circuit देखिए, like we have our internal resistance R and this is an external resistance capital R. Okay, so in this case V is equal to voltage between this R. So that we can say equal to I into R. Okay, so if current is given, you can substitute that here. So E by I minus R, you will get internal resistance R. Okay. So first this is about like one cell. अगर हम इसको सीरीज और पैरेलल कनेक्ट कर रहे हैं तो what will happen to as effective EMF. Okay, when we are connecting in series, it will get directly added up, E1 plus E2 plus E3 etc. Okay, and you have to see if it is connecting positive to positive or negative to positive, like that. If it is connected negative to positive and the next negative to positive, we will directly add V1 plus V2 plus V3. But ऐसा कनेक्ट किया है like negative terminal connected to negative terminal, then we have to subtract it. For example, if the connection is like this, E1 E2, we will add E1 plus E2. But if the connection is like this, okay, E1 E2, we have to see E1 minus E2. Understood? Okay, that is in case of series connection. और इसका resistance भी है ना, वो भी हम directly add करेंगे. resistance भी series में connect किया है, ऐसे assume करके R1 plus R2 we will take. In this case also it will be R1 plus R2 only for resistance. Resistance we are not going to minus. Okay, this is series connection. Parallel connection में आते, how we will find is E equivalent is equal to E1 by R1 plus E2 by R2 plus E3 by R3 etc. into R equivalent. For parallel connection, equivalent resistance is found like this. Okay, and plus or minus in this, between this will depend on connection. Okay, negative positive कैसे connect किया है, like this connection can also be possible and like this connection can also be possible. तो इस पे डिपेंड करता है कि ऐड करना है या माइनस करना है. एंड R equivalent we will find as if all internal resistance are connected parallelly. Okay, so if I am erasing this, R equivalent equal to 1 by R equivalent, 1 by R1 plus 1 by R2 plus etc. R equivalent हमें parallel connection जैसे find करना है, फिर substitute करना है. Is that clear for all? Okay, so this is regarding grouping of cells. Then the common question you will get is n number of cells connected in series for m rows. This type of question, one PYQ I have added, that when we will solve you will understand it better. Okay, I am not going to explain it now. Then we have KVL and KCL. Kirchhoff's current law, what does it say? अगर एक junction हम ले रहे हैं तो total sum of current in that junction will be 0. Okay, if you add all the current in that junction it will be 0. और in other words ऐसे बोल सकते हैं, जितना current junction पे आ रहा है उतना current junction से leave करेगा. Okay, that is the basic meaning of that. Then coming to KVL, it might be little complicated. See, total potential, if you add in one loop, you will get 0. Total potential in one loop is 0, which means its simple meaning is this. We have one battery, right? This battery is providing potential to this thing and this thing. Okay, so its potential is divided between here R1 and R3, which means potential across R3 plus potential across R1 will be equal to our battery EMF. Okay, so when you substitute in everything to the LHS side, you will get E minus VR3 minus VR1 equal to 0. This is how you get that formula. Okay, एक ही बैटरी है जो प्रोवाइड कर रहे हैं इसके लिए पोटेंशियल. सो इफ यू ऐड all them together you will get 0. Understood the meaning of this? ओके, सिमिलरली दूसरे लूप भी हम ले रहे हैं तो उसमें भी यही बैटरी डिस्ट्रीब्यूट कर रहे हैं ना, इसका पोटेंशियल जो इस साइड है वही उस साइड में भी होगा. सो EMF of this side will be distributed with R2 and R3. Same on this side also. जब हम combine करेंगे, like if you want a side, इस side में I1 current होगा, इस side I2 current होगा. So here you will substitute is at I2 R2 plus I2 R3. Here it will be I1 R3 plus I1 R1. ऐसे सब्सटीट्यूट करके हमें सॉल्व करना है. क्लियर?
हम रिपीट.
ओके, विच लैंग्वेज डू यू वांट?
इंग्लिश.
Okay, so what I was saying is that one battery is there, it is distributing voltage over this branch, right? One, like if you connect one battery to two resistance, we can say that potential is being distributed across two resistance. It is having EMF that will be split for R1 and R2. Okay, so this is R1, this is R2. Potential across R1 is V1, potential across R2 is V2. Then I can say this, right? EMF, total EMF is equal to V1 plus V2. Same thing we are doing here also. But if you write everything to the RHS side, LHS side, you will get this. Okay, and how to solve this? We are assuming that some I current is flowing. Okay, I current is flowing, then EMF will be equal to IR1 plus IR2. Like this you can solve it. For I, R1, R2 EMF given, you can find I. That is our aim, how we solve. Now clear? Okay, moving on. Next is Wheatstone bridge. In this also I am not going with explanation. It is not required because हमें directly इसका balancing condition ही देखना है. अगर इसमें like RA by RX equal to R1 by R2 इस condition में है तो I in this branch will be 0. Okay, अगर Wheatstone bridge में ऐसे जो आ रहा है वो balance like equal है, ratio equal है, तो current through this branch will be 0. In that case, what if Rx is not given? We can find Rx equal to what? RA by R1 into R2. Like 3 resistors दे रखे हैं, 1 नहीं दिया है तो और बोल रहे हैं कि balancing condition में है, then you can find the resistance which is not given by other resistors. Okay, is it clear? This is the main application of Wheatstone bridge. So based on Wheatstone bridge principle, we have a device that is meter bridge. Meter bridge में भी same application कर रहा है because there is a wire of certain resistance connected and 2 resistance here. This is that middle branch. Okay, तो galvanometer में 0 deflection मतलब like middle branch में 0 current. In that case जो इस साइड का resistance है उसका ratio और इस साइड का ratio will be equal. Let's take but resistance is proportional to length, right? Because resistance equal to rho L by A. If you are taking this wire, both are having length only difference. A and rho is same. So we can say that here resistance is proportional to L1 and this side resistance is proportional to L2, whatever that length is. And that L2 is nothing but what? 100 minus L1. Okay, so if R नहीं दिया है, S दिया है, you can find R equal to SL1 divided by 100 minus L1. So with just balancing length you can find unknown resistance. That is the application of meter bridge. Is that clear?
Excuse me, ma'am.
Yes.
Ma'am, if they ask in this type of question, when they will change the heater scale into copper working, they'll ask where is the null point.
Yes.
How to find that null point?
Yes, we just found that in similar question in mock test, right? Previous one. So what happens is that if R and S is not changed, length should not change, right? Because ऐसे देखिए, like R by S should be equal to L by 100 minus L. अगर R रेसिस्टेंस और S में चेंज नहीं है तो इस L में भी चेंज नहीं आना चाहिए. ओके, रेशियो शुड बी सेम, विच मीन्स अगर किसी भी वायर हम ले रहे हैं तो इसका रेशियो सेम ही रहेगा. इट इज़ नॉट गोइंग टू चेंज. इज दैट क्लियर? ओके. नेक्स्ट इज व्हीटस्टोन ब्रिज अगर बैलेंसिंग कंडीशन में नहीं है. व्हेन द व्हीटस्टोन ब्रिज इज नॉट इन बैलेंसिंग कंडीशन, then how we will solve it? So that time we have to use this conversion. Okay, so just think like this. This will be our like Wheatstone bridge and current will be passing through this branch. तो हम ऐसे करते हैं, इसको ऐसे डेल्टा ले लेते हैं. ओके, दिस एरिया we will consider as a delta and we will convert it to star, or we can consider a star and convert it to delta. So what we will do here is, for example, okay, here it is given star to delta conversion. Okay, if you find a star point, okay, from this point 3 are coming, so this is a star point, you can convert that to delta. How you can convert? It will become like this. Okay, so this one I am considering as star. This will be R1, this will be R3 and this will be R2. Okay, in such case you can convert it like this. Okay, like this conversion is possible here. Then what will happen? This will become R23, this will become R12, this will become R13. Like this it will be converted. Okay, in that case this is the conversion formula which we will use and new resistance can be found. If this is the case, R12, R13 they are in series, we can directly add. This one and this one series we can directly add and all three will be parallel. So solution became simple. Clear? I am taking this point and considering it as a star point and I am converting that to a delta configuration. Okay, similarly we can do the opposite also. If you consider a delta, you can convert into star. That is don't worry, today we are not doing any problems with this and I don't think you will get much problems from this also, but in case if required you should be able to. That's why I am giving you the formulas. Okay, next is delta to star conversion. In that case, this is our Wheatstone bridge which is not in balancing condition and this we are considering as a delta. Okay, on conversion it will become like this. Okay, so here I am considering this is R12, this is R23 and this will be R13. You have to name it properly, then only you can convert. Okay, So R12 and R23 together it will form R1. Sorry, R2. Okay. Then R12 and R13 together it will form R1. Here it will be R3. So for further understanding, I will send you this PPT like this only. You can refer to this. Okay. I am not hoping you will understand it in this one class. With more problem solving only you will understand. Can we move on? When we convert like this, it becomes easier, right? R1 and this series, this two series, you can directly add. So this is only to be used when you have a Wheatstone bridge in unbalanced condition. Otherwise it's fine. Clear? Since nobody is replying, I am thinking like you guys did not understand this. No problem, we will see later. Okay. Last topic for this chapter is moving coil galvanometer. Okay, this is really important. One thing you need to know about torque of in moving coil. इसका working principle क्या है? Like two magnets के बीच में tightly wound wire है, तो वो क्या, when the current passes through it, it will also create magnetic field, and because of that deflection will happen. So based on that, the torque equation is this, or if you want you can write it as torque equal to BINA, name BINA. Okay, torque you can remember like this, torque is BINA. B is magnetic field of this magnets, I is current passing through it, N is number of number of wounds of the wire, and A is area of cross section. Okay, so based on this you will get torque. Now this is conversion of galvanometer to ammeter. This is from galvanometer to voltmeter formula. Okay, if we have to convert galvanometer to ammeter, we should connect a resistance parallel to the galvanometer. This resistance is called as shunt resistance. So shunt resistance कैसे calculate करना है? अगर आपको like I value तक like galvanometer से measure करना है, तो this will be the calculation for shunt resistance S. Okay. Similarly, converting galvanometer as voltmeter, you have to connect a resistance in series with the galvanometer. Okay, तो आपको V value तक volt को measure करना है. This is how you find what is the resistance that you should connect in series. G is nothing but resistance of galvanometer. Okay, G is resistance of galvanometer. You can convert galvanometer as ammeter by connecting a parallel resistance. Galvanometer to voltmeter, connecting resistance in series. To calculate these values, we have these formulas. This one is for finding current sensitivity. Not this. Current sensitivity, this is different formula. Current sensitivity we can find as theta by I. Let's say for 1 ampere current, deflection is 30 division. So one division में कितना current measure होता है, वो है current sensitivity. So number of divisions divided by total current, you will get current sensitivity. And if you find theta by I, what you will get? Theta by I equal to NBA by 2K. Okay, so this is current sensitivity. This is voltage sensitivity. Voltage sensitivity कैसे calculate करना है? That is equal to current sensitivity by G. Okay, not G, sorry, R. Which R is this? जो series में हमने connect किया है ना, same R we have to use here. These are the formulas related to galvanometer. Is that clear?
What is K?
K is a constant for like that torsional, sorry, not torsional, restoring constant is there, no, for galvanometer. It will be given in the question. K is the restoring constant, K. Okay. Okay. I hope that's clear for all. Torque, conversion to ammeter, conversion to voltmeter, current sensitivity, voltage sensitivity. That's it. Now let's start with our problem solving. Why 2K? Like it comes in the derivation. We are not going into that. That's why. So let's try this question. Current passing through the battery, that is 5 volt in the given circuit. If हमें करंट लाइक करंट जो टोटल करंट है वो फाइंड करना है, फर्स्ट वी हैव टू फाइंड इक्विवेलेंट रेजिस्टेंस. सो बेसिकली दिस क्वेश्चन सेज फाइंड इक्विवेलेंट रेजिस्टेंस देन फाइंड करंट. ओके, इक्विवेलेंट रेजिस्टेंस फाइंड करने के लिए हमें यहाँ पे कुछ कॉम्प्लिकेटेड सा दिख रहा है ना, बट इफ यू रीड रो दिस हाउ इट विल लुक. Okay, it will become a Wheatstone bridge. This is point E, this is point B, this is point A, this is point D. Okay, so you are getting a Wheatstone bridge basically 3 1.5, 5 2.5, and what are we getting? That since ratio is same, there is no current passing through this AD. इसमें करंट पास नहीं हो रहा है, सो वी कैन सिंपली मेक इट एज लाइक दिस. ओके, वी कैन रिमूव दिस AD branch only. So you will have 3 5 1.5 2.5. What is the equivalent resistance in this? It will be 8 and 4, not 4.
Option.
Sorry, option? I didn't hear. C. Yes, C is the correct answer. Find the equivalent resistance here, then find the series here, series resistance total, then divide it with 5 by equivalent resistance. You will get the answer, current. Okay, is it clear for all? Okay, sorry, actually current is 0.5 ampere. Did you make a mistake somewhere? Here 1 by 8 plus 1 by 4 will come, and when you add you will get equivalent resistance 8 by 3 for this combination. So you will have here 1.5 that can be written as 3 by 2, 5.5 that can be written as 11 by 2, then there is 1 by 3. So you have 3 by 2 plus 11 by 2 plus 1 by 3 plus 8 by 3. This will be R equivalent. Then I will be equal to 5 volt divided by R equivalent. Now find R equal to 10 ohm. Which R? Okay, this R equivalent. Okay, R equivalent 10 ohm. Yes, so this will be 1 by 5, 5 by 10 equal to 0.5. That is our current. Okay, I hope you understood this. Next one, resistance of a wire at room temperature is room temperature 30 degrees Celsius is found to be 10 ohm. Now to increase the resistance by 10%, the temperature of the wire must be like total हमें 10% increase करना है, तो what will be the like new temperature of the wire? That is the question. So let's assume that temperature resistance at 30 degrees Celsius is equal to some value of R naught into 1 plus alpha delta T. यहाँ पे डेल्टा टी मतलब 30 डिग्री सेल्सियस इज और फाइनल टेम्परेचर, इनिशियल टेम्परेचर इज 0, सो दिस इज इंटू 30. Okay, alpha is given, right? Alpha is given as 0.002, that is alpha value. Now R30 is equal to 10 ohm, that value is also given. We know that new temperature is 10% more than this. So what is 10% of 10? That is equal to 1. Okay, so new resistance is equal to 11 ohm. This R30 plus 10% of that will be 11 ohm. Then we will get 11 ohm is equal to R naught into 1 plus alpha some T. That T only we have to find. So we have two equations here. This is equation 1, equation 2. Two unknowns, R naught and T. You can find, right? Two equation, two unknowns. If you divide with each other, R naught will get cancelled. Then you can solve for T. Is there any doubt in how to solve this? Did not understand or no doubt? Did not understand. Okay. We have this equation, right? Resistance at any temperature. How you can find resistance at any temperature equal to resistance at 0 degree Celsius into 1 plus alpha delta T. Okay, change in temperature. In here at 30 degrees Celsius, when T equal to 30, resistance is given as 10 ohm. Okay, so delta T, alpha is given at 0 degree Celsius, right? So temperature difference will be 30 minus 0. So that's why it is written 30 here into alpha plus 1 into some resistance at 0 degree Celsius. That's how this equation comes. Similarly, 10% increase is there. Okay, so RT is equal to R at 30 plus 10 by 100 into R30. That value we are getting as 11 ohm. For RT, any temperature, we can again apply this formula. So that's why we are applying same formula for 11 ohm also. Now in this, but temperature we don't know. That is what we have to find. So we get two formulas. Now you can find 11 by 10 is equal to 2 by 1 equal to what? R naught into 1 plus alpha T divided by R naught into 1 plus 30 alpha. R naught cancel. Yes?
33 degrees Celsius.
Sorry, it is not 33.
Okay.
Option B is the answer, 83. Okay. So from this you can solve for alpha. T. Alpha is given, please substitute that value. अगर आपको ऐसा नहीं करना है, this will exactly give you 83 degree Celsius. अगर आपको ऐसा नहीं करना है, simple method है, but आपको correct value नहीं मिलेंगे. That is, we assume that R at T we have to find, which is equal to R30 into 1 plus alpha 30 minus, T minus 30. 1 plus alpha T minus 30. हमें 30 बेस रख के हम कैलकुलेट करेंगे. In this we know that this is delta R. Okay, so this is basically R30 plus delta R, which will give us RT. delta R is this value. Okay, that is nothing but 1 ohm. So we can say 1 ohm is equal to R at 30 into alpha t minus 30. ये सॉल्व करके भी आपको t मिलेगा, बट हियर यू विल गेट द आंसर t इक्वल टू 80. एग्जैक्ट वैल्यू नहीं मिलेंगे, अप्रॉक्सीमेट वैल्यू मिलेंगे, वो बेस में आपको करेक्ट चूज करना है. इज दैट फाइन? Like two methods, one is exactly as we should do, you will get exact answer. One you will get approximate answer. Fine? Do you have any doubt? Can you explain the second method again, please? Okay. Yeah, like here what we are doing, we are assuming that at 0 degrees Celsius it is defined. So RO plus R30. Okay. So RO plus 1 plus alpha T will be resistance at 30. We are getting two equation. Instead what we are doing, we are assuming that alpha is mentioned for 30 degrees Celsius. In that case, at T degree Celsius, it will be R30 plus 1 plus alpha delta T. Okay, so 30 degree we are keeping as base. So change in temperature will be T minus 30. Here it is T minus 0. Here 30 minus 0 is coming. Instead, directly it will be T minus 30. And we are writing it as, like, if you open the bracket, R30 plus delta R, like what is the change in R, that will come, right? Delta, like this. So new resistance equal to R30 plus 10%. That 10% we are finding to be 1 ohm, delta R. So delta R will be equal to the second term that we are equating directly and solving. But you will get approximate value of T only. Is that clear? Okay. Next one. A wire of resistance R is cut into 8 equal pieces. From these pieces, 2 equivalent resistance are made by adding 4 together in parallel, and these two sets are added in series. Net effective resistance we have to find. First what we are taking a resistance R. It is having, let's say, L length. Okay, L length. If we cut it into 8 pieces, equal pieces, हर एक पीस का रेसिस्टेंस क्या होगा? each piece will have resistance R by 8 because we are cutting into 8 equal pieces. Okay, फिर हम क्या कर रहे हैं, उसको 2 sets बना रहे हैं, like 4 pieces we are connecting as parallel, then connecting it as series. This is what we are doing. One wire we cut it into 8 pieces. Out of that 4 pieces we are adding parallel and make it 2 sets, then make them connect in series. Okay, so each individual is having R by 8 resistance here. So what will be equivalent resistance of this combination? That is the question. R by 16. Okay, how are we getting that? Parallel combination, equal resistors are having, then we can say that R by number of connections will be equivalent resistance. So this will be R by 8 divided by 4. Then here also R by 8 divided by 4. When we add them, 2 into R by 8 into 4. So you will get R by 16 answer. Is it clear for all? Okay. Next one. The plot represents the flow of current through a wire at 3 different time intervals. Ratio of charge flowing through the wire corresponding to these time intervals. So, dq by dt is equal to current. In that case, we can say that charge is equal to I into t, right? So basically from graph, if you want to find graph से अगर ऐसे relation में like differential का opposite find करना है, तो what will be, you have to find area under the graph. If you find area under the graph, you will get the opposite of differential. Okay, that is basically integration. So this area you will get Q1, this area you will get Q2, this area you will get Q3. Then find the ratio. Here it will be 2 into 1. Time change is 1 second and current is 2 ampere. So 2 into 1. Here Q1 will be equal to 2. Q2 1I into 2 seconds. So it will also be 2. Q3 will be half BH. Okay. Half B. Yes. This will also be 2. So ratio is 1:1:1. Very good. Okay. Everybody else also understood this? Okay. Let's move on. Next one second. I hope everybody can see the question. A constant voltage of 50 volt is maintained between the points A and B and current through the branch CD. So, in this case, what is current through branch CD? That is the question. First check if it is in Wheatstone bridge like balancing condition. Is it in balancing condition? If it's in balancing, no. If it's in balancing, we can say there will be no current. Since it's not balancing, we have to find it like this, okay? Okay, this is 1, this is 3, 2, 4. What we have to do is that we are assuming total current I is coming, I1 is going through this direction. So through this direction it will be I minus I1. At this point I1 is split, I2 will go here. Here it will be I1 minus I2, and from at this point what will go? I plus I2 will come through. Sorry, not I plus I2. What will go here? I minus I1 plus I minus I2 will go through here. I1 minus I2. Okay. We only need to find I1 and I2, and I1 minus I2 will be current through CD. Okay. Current through CD will be equal to I1 minus I2. You have to find I first. Total current first we have to find. Total current how we will get? Find the equivalent resistance, then 50 by R equivalent will be equal to total current I. This will be 1 by 3 plus 1 is equal to 1 by R1. Here 1 by R2 is equal to 1 by 2 plus 1 by 4. Then R equivalent equal to R1 plus R2. R1 how much we are getting? R1 we will get as 3 by 4. Okay, and R2 we will get as R2 equal to 4 by 3. Okay.
Total current is 24 ampere.
Yes, total current equal to 24 ampere. Now how to find? I is coming here, right? And it is splitting through this branch as I1. How to find this? For finding I1 we have a simple formula, that is I is equal to R2. Okay, let's say this is R2, this is R1. So R2 into I divided by R1, R equivalent. Okay, R1 plus R2. Current through first branch. How this formula is coming is, these two ends have same voltage difference, right? So we will get I1 R1 equal to I minus I1 into R2. By solving this we are getting this equation. Somebody already got the answer, 2 ampere. Yes, good. Okay, in this way you will get I1, and similarly you have to find I2 also. I2 also, here I2 is coming, here some other current is coming, you will get I. So same way I2 also you can find in this equal to I into, if in this case this is R3 and this is R4. Okay, I R3 divided by R3 plus R4. Here this R equivalent. Then finding I1, I2, you can find the difference. This one you are getting it as 18 ampere, and this you are getting as 16, I think. So difference equal to 2 ampere. Is that the value you are getting? Are you guys solving this or done solving? Can we move to the next question? If you are still doing calculation, I guess we can move on because we don't have much time. Okay. Answer is 2 ampere. Okay. Next one. This is the type of question I told you that we will see in PYQ. Okay. So there are n rows, each containing m cells in series. So n rows are there. N number of rows. Each are having m cells in series. Okay. Like this. So that is first thing. Then these are joined in parallel, n rows parallel. Maximum current taken from the combination across external resistance is 3 ohm. So maximum R equivalent is given as 3 ohm. Okay. Then we are assuming that all the cells are identical, so their internal resistance also identical. Then if the total number of cells are 24 and internal resistance of each is 0.5 ohm, total number of cells equal to 24. So if m cells are connected in series across n rows, total number will be m into n, which is equal to 24. Understood? Like 4 cells are there. In 10 rows means 4 into 10, 40 cells will be there, not total, like that. Next, R equivalent is given, individual R is also given. Okay, if connected in series, total resistance will be what? MR, right? So MR, then connected in parallel across n rows, so divided by n is equal to 3 ohm. Okay, individual R is equal to 0.5. So we have equation 1, equation 2. With this you have to solve M and N with these two formulas. Okay, substituting R equal to 0.5, we will get M by 2N equal to 3 ohm. From here, Mn equal to 24. Okay, then from this we can say that M equal to 6N. Okay, M equal to 6N. Substituting it here, we will have 6N square equal to 24, N equal to 24 by 6, 4, root equal to 2. Yes, answer is option C. Only one option is having N equal to 2. Okay, is that clear for all? 3 is external resistance or resultant internal resistance. They are saying maximum current taken is equivalent to 3 ohm resistance. So internal resistance sum should also be equal to 3 ohm. That's what. Now understood? Okay. Next is a uniform wire of diameter d carries a current of 100 milliampere when the mean drift velocity electrons in wire is V. Wire of diameter d by 2 of the same material to carry current of 200 milliampere. Find the drift velocity of second one. So drift velocity of first one equal to V. Okay, what is the relation between drift velocity and current? I equal to NEAVD. So drift velocity is equal to I by NEA. Okay, in the first case, this is equal to current is given as 100 milliampere divided by NE not given, so we will not substitute. Area is given by diameter is d, so radius equal to d by 2, area equal to pi into d square by 4. Okay, this is for drift velocity of 1. Drift velocity of 2 is equal to what? Current is given as 200 milliampere, NE same only, it will not change, and what? Wire diameter is d by 2, radius d by 4, which means area pi d square by 16. If you want to find drift velocity of 2, you have to find 2 divided by 1 and solve. B. Okay, correct only. Everybody got that answer? Is everybody getting the answer or others are not solving?
D square by 16 from where it is come?
Which one? D square by 16. Area is pi r square, right? So for second case, diameter is given as d by 2. So radius is equal to d by 4. Substituting that here, we will get pi d square by 16. Clear? Okay. If everybody understood this, we can move to the next question. Okay. Next one. A wire is connected to 220 volt main supply, have power dissipation P1. Now the wire is cut into two equal pieces which are connected in parallel to the same supply. Power dissipation is P2. What is P1 is to P2 or P2 by P1. Okay. Now let's talk about wire. If it is connected, some R is connected across V voltage. Okay. Our power is equal to, power have multiple equation. One is V into I, another is I square R, another is V square by R. Since we are talking about parallel connection, it is easier to solve with V because V will be same. So take this equation. Okay. So we can say P1 equal to V square by R1. Okay. First case. Then V is given 220 volt. We don't want that. Okay. Now go to second one. The same resistor R is connected to two parts. So individually it will have take it as R only. P1 equal to V square by R. Now R is cut into two pieces. Okay. So each is having R by 2 resistance. Now they are connected in parallel and connected to the same supply. So what is the equivalent resistance here? R equivalent will be equal to R by 4. Okay. Now the power dissipation in this, V did not change, right? So V square by new R equivalent, that is R by 4. Now P2 by P1, if you are finding, what you will get is equal to 4. Yes, option B is the answer. Understood how we are solving it? Okay, similar thing I have seen, like one wire is there, one another type question. Okay, one wire is there. Now we make it into circle. Then what is the resistance across any diameter? You can try that question also. Okay, one wire is made into circle. So across any diameter you have to find equivalent resistance. Okay, wire is having total R resistance, that you can try. Next one, a uniform metal of wire length L has 10 ohm resistance. Now this wire is stretched into length 2L and bent to form, okay, same question only, sorry, we can do here only. Bent to form a perfect circle, equivalent resistance across any arbitrary diameter of the circle. Okay, so uniform metal of length L has 10 ohm. So R equal to rho L by A. L length R is equal to 10 ohm. Now L is doubled, like it is stretched to become 2L. So new R is equal to what? Rho into 2L by A. A dash. Okay, we don't know what is A dash, but we have a relation from before, right? What is that? L1 A1 equal to L2 A2. So if you want to find A2, that is equal to, here it is A, L1 by L2 into A. Okay, what is this? L1 is just L, L2 is 2L into A. So A by 2. Substituting that here, you will get 2 into 2 by A by 2. So you will get it as 4R. Right? This is R, which means R dash is equal to 40 ohm. Is that clear? Resistance of the new wire, like after stretching. Okay, now what they are doing, they have made it into a circle and across any diameter they are asking. So if we are connecting like this is having half length and this is having half length, which means this will have R dash by 2 resistance, this will have R dash by 2, and they are connected in parallel. So this combination will have R equivalent, that is equal to what? R dash by 4, which means R dash is 40, R equivalent will be 10 ohm. Is it clear for all? I hope there is no doubt in this problem. In that case, we can move on. Next one. In the electric network shown, there is no current flowing through 4 ohm resistor in the arm EB. Potential difference between point A and D. Okay, there is one particular method for solving questions like this. That is, like, multiple cells are there, right? We have to apply KVL or KCL, but it will take more time if you are applying KVL and all. So what we will do is that this also negative, this also negative. We will ground this place. Okay, ground this place. So we will get from one end, here voltage is 0. Grounding means. So this place A will have voltage 9. Okay, because across this it should be 9 and across this it should be 3. Here voltage will be 3 volt. Okay, A and C we got. Now if you take, let's take here, across this resistor no current is flowing. No current is flowing means here it is 4 volt. Here then it should be also 4 volt. Okay, here also 4 volt. Clear? Because at equal potential difference there will be no current flowing. So here also it should be 4 volt. Then since here it is 3 and here it is 4, at D what will be the potential? D and E both are same points, right? If you see, both are like same point only. So D 4 volt is there. We want to find difference between A and D. A is 9, D is 4. Difference will be option C, 5 volt. Okay. So this is one method, like we will ground one point. According to that we will find voltage at different different junctions. Okay, this is how you solve such question where multiple cells are present. Is that clear? If you are applying KVL and all, it will take long time. So this is easy method. If it's done, then we will move to the next question. The given circuit shows a uniform straight wire AB of 40 centimeter length fixed at both ends. In order to get 0 reading in the galvanometer, free end J should be placed at what distance? So this distance they are calculating as L. We want to find L. Total distance AB is given as 40 centimeter. So this length should be 40 minus L. Same meter bridge configuration, but instead of 100 centimeter, total length is 40 centimeter. So here we can say 8 by 40 minus L is equal to 12 by L. Solve for L. D, 24 centimeter. Okay, that is the answer. I don't think there is much complication in this. Everybody can solve, right? Okay. Then we can move on to the next question. Okay, in the figure shows a meter bridge circuit x equal to 12 centimeter. Okay, x equal to 12 centimeter, R equal to 18 ohm. The jockey J is at null point. If R is made to 8 ohm, jockey have to move by 4 into A centimeter to obtain null point again. Find the value of A. Initially it is some point L. Okay, let's say this is length L and this will be 100 minus L. Then we can say that 12 by L equal to 18 by 100 minus L. From this we can solve what is the value of L. Second, what they are doing, they are making 18 ohm to 8 ohm. Then jockey have to move further by what? L plus 4A. So new length 12 divided by L plus 4A equal to 8 divided by 100 minus this, let's say this is L plus 4A, so 100 minus L plus 4A. This is new equation. First find L from this, substitute L here, solve for A. Is the method clear? If you get the answer, just mention. From this you will get 12 into 100 minus 12L equal to 18L. 12 into 100 equal to 18 plus 12, that is equal to 30L. L equal to 12 into 100 by 30 equal to 40 centimeter. Okay. Then we can substitute L equal to 40 here and solve. Option B. Everybody got that? I hope so. So, answer is option B. Okay. If there is no doubt in this, can we move to the next question? Next one, the terminal voltage of battery whose EMF is 10 volt and internal resistance 1 ohm when connected through external resistance of 4 ohm as shown in the figure. We have only one equation for this. That equation is V equal to E minus IR. And how to calculate I? I is equal to E divided by R plus R. Okay, total EMF by total resistance will be current. So that will be equal to 10 divided by 5 equal to 2 ampere. E is given, I is given, R is given, you can find V. V equal to option C, 8 volt. Okay, yes, good. So such questions will be easy. So sometimes direct without much calculation also you will get the answer. That's why current electricity more questions. We saw in the orientation, right? 38 questions from this 42 questions from this chapter alone. Next one, this one might take some time to solve. A heater boils certain quantity of water in time t1. Another heater boils the same quantity of water in time t2. Both heaters are connected in parallel. Combination will take how much time? Here what we are saying is like how much heat energy required. Okay, heat energy is required to boil water, right? Same amount of water, same amount of heat. How we will get heat? Heat is equal to power into time. Okay, so we have equations I square RT or V square T by R. Such equations are there. Since we are talking about parallel connection, I told you we will take V with the voltage. So for first one, heat will be same for both and voltage is also same. So V square T1 by R1 equal to H. Second one, H is equal to V square T2 by R2. For third cases, we are connecting these both parallel. So we want to find equivalent resistance. H is same, V is same. So we can get R1 equal to V square T1 by H. From this, R2 equal to V square T2 by H. Equivalent resistance, R equivalent equal to 1 by R1 plus 1 by R2. Or directly you can find R equivalent equal to R1 R2 divided by R1 plus R2. Direct also you can substitute. Once you get R equivalent, again heat is same, voltage is same, divided by R equivalent into T. This time you have to find. So time taken will be equal to H by V square into R equivalent. Just find R equivalent from this. See, R1 R2 by R1 plus R2 directly proportional to T1. So without T1 much calculation, can we say answer is option C? Oh, sorry. Can I say that? Because both are proportional to T1, T2, right? So I hope you understood this. Even if you calculate, you will get the answer. Without calculation also, I am trying to tell that since equation looks same and proportionality is same, we can get answer like that. Is it clear for all? Okay, so time is 11:30. I am stopping here. Few more questions are like, I think 4 or 5 questions are also extra there. Please try them. Okay. And one additional point I forgot to tell you guys. Okay, in the power equivalent. Okay. In the grouping of cells, we talked about maximum power transfer source. No, that's why I think Surabhi got that out. Maximum power transfer will happen if internal resistance equal to external resistance. One condition is there. Okay, maximum power transfer occurs when internal resistance equal to external resistance. That's why in that M cells and N row question, we assumed internal resistance equal to total external resistance. I forgot to mention this here. Okay. If that's done, you guys can leave the call, and tomorrow we will meet for next chapter, capacitor, and today 12 o'clock you will have to join for chemistry class. Thank you all.